100 million years ago, during the Cretaceous period, the area we now know as the Amazon rainforest was part of a shallow sea that covered much of South America. When the Andes Mountains began to form around 65 million years ago, due to the collision of the South American and Nazca tectonic plates, the region's river systems changed dramatically. Previously, rivers flowed westward, but as the Andes rose, the flow reversed and began heading eastward, toward the Atlantic Ocean. This shift created what we now call the Amazon Basin, a vast ecosystem spanning nearly 7 million square kilometers, acting as the green lung of the planet. Over time, tropical rainforests began to develop, rooted in ancient plant species that had adapted to humid environments. Gradually, they gave rise to one of the most biodiverse ecosystems on Earth. Tens of millions of years, the Amazon has become home to and a cradle for the evolution of millions of species. Among them are piranhas, anacondas, jaguars, macaws, capuchin monkeys, army ants, and the towering kiba tree. Each species carries its own unique evolutionary history, shaped by complex relationships of symbiosis and competition. What makes the Amazon especially remarkable is its incredibly high level of endemism. Many species of plants, insects, and birds are found nowhere else on Earth. The rainforest is a constantly evolving engine of life, where every creature plays an irreplaceable role in the food web and the delicate ecological balance. Contrary to the common belief that the Amazon rainforest is a pristine wilderness untouched by humans, archaeological evidence shows that humans have lived here for at least 11,000 years. Indigenous communities such as the Yanomami, Kayapo, Ticuna, and Ashaninka learned to live in harmony with the forest. They developed rotational farming techniques, established forest gardens, and made extensive use of natural medicinal plants. Many modern scientists now believe that the Amazon is not solely a product of nature, but also the result of thousands of years of sophisticated environmental stewardship by indigenous peoples. Rather than destroying the forest, they nurtured and regenerated it. Recent archaeological discoveries have uncovered large ancient settlements, intricate networks of canals, raised fields, and man-made mounds, evidence that a thriving civilization once existed in the Amazon long before European contact. In 1541, Spanish explorer Francisco de Orellana became the first European to navigate the Amazon River. He named it Amazon after encountering fierce female warriors who, according to him, resembled the mythical Amazons of Greek legend. From that point on, the Amazon rainforest began appearing on world maps, but it also marked the beginning of a long era of conquest and exploitation. Thousands of indigenous people were enslaved, exposed to European diseases to which they had no immunity, leading to the collapse of many native communities and the loss of vast stores of traditional knowledge. In the 19th century, the Amazon entered the era of the rubber boom. Natural latex was harvested on a massive scale to supply European industries. The city of Manaus in Brazil grew wealthy from the rubber trade, but this wealth came at the cost of brutal forced labor, violence, and the exploitation of indigenous populations on an unprecedented scale. The Amazon rainforest holds evolutionary secrets spanning tens of millions of years, a living museum of biodiversity. From tiny insects to massive animals, every creature in this ecosystem is the result of a long chain of genetic mutations, environmental adaptations, and intense natural selection. The Amazon is a paradise for insects, accounting for over 60% of all species in the rainforest. Army ants exhibit collective hunting behavior. Termites build towering earthen fortresses up to 2 meters high. And beetles, butterflies, stingless bees, and thousands of mosquito species all play vital roles in maintaining ecological balance. Some insect species remain completely unknown to humans. It is estimated that the Amazon alone may harbor around 2.5 million insect species, many of which have yet to be named or studied. Certain insects have evolved remarkable mimicry adaptations to survive. For example, swallowtail butterflies imitate the appearance of toxic species to deter predators, while cicadas spend over a decade hidden underground as part of their life cycle, avoiding predation. It can be said that the Amazon is the kingdom of ants. This rainforest is home to thousands of ant species, each with distinct roles and behaviors, from leafcutter ants to army ants, each group employing its own survival strategies. Leafcutter ants don't eat the leaves they collect. Instead, they bring them back to their nest, cut them into smaller pieces, and use them as a substrate to cultivate fungus, the colony's primary food source. This is a prime example of insect agriculture. Their colony operates with a clearly defined division of labor: soldiers for defense, workers for transport, and nurse ants that tend to the fungal gardens. Army ants, on the other hand, do not build permanent nests. They live in massive colonies of hundreds of thousands, constantly on the move, hunting in coordinated swarms that devour everything in their path. When resting, they form a living nest, a protective structure made of thousands of ants interlocking their bodies to shelter the queen and larvae. The organizational structure of an ant colony can be likened to a superorganism, where each ant functions like a specialized cell, working together to power a vast and complex biological system. Ants are remarkable not only for their organizational skills, but also for their sophisticated reproductive strategies and nest-building behaviors. In the Amazon, where the warm and humid climate creates ideal conditions, the reproductive and social structures of ants reach a level of complexity that can be described as almost civilized. An ant colony is considered a superorganism, where each individual functions like a cell within a collective body. Within this system, key roles include queen ant, the only individual in the colony capable of reproduction. Her sole task is to lay eggs, sometimes thousands per day. Depending on the species, a queen can live for 10 to 20 years. Male ants. Their single role is to mate with the queen during a brief period, after which they die. Males typically appear seasonally for mating flights. Worker ants. These are sterile females responsible for nearly all tasks within the colony: searching for food, tending to the larvae, defending the nest, constructing tunnels, and keeping the nest clean. Soldier ants, a specialized form of worker ants, larger in size and equipped with powerful mandibles. Their primary job is to defend the colony from intruders. Male ants mate with multiple females. After mating, the female sheds her wings and burrows into the soil or into decaying wood to start a new nest. This marks an incredibly harsh survival phase. The young queen must survive alone for several days or even weeks, relying only on her stored fat and by metabolizing parts of her body, such as her wing muscles. She lays her first batch of eggs, which develop into small worker ants. These first workers take on the initial tasks: expanding the nest, foraging for food, and caring for the next generation of eggs. The first nest is tiny and highly vulnerable to predators and environmental threats. The success rate for queens establishing a colony is typically under 5%. However, if the queen survives this critical stage, the colony can eventually grow to millions of individuals. After mating, male ants die. The fertilized queen carries stored sperm and flies off in search of a suitable location to establish a new colony. In the Amazon, ant nests can be extraordinarily complex, especially in species like Atacephalotes, leafcutter ants. A single nest may span up to 30 square meters in surface area and reach 8 meters deep underground, contain thousands of interconnected underground chambers, including rooms for egg incubation, fungus farming, resting, ventilation shafts, and climate regulation systems. Each chamber has a specific purpose and is actively maintained by worker ants. The ventilation system is naturally engineered, with air shafts at the surface creating convection currents that regulate temperature and humidity, ensuring optimal conditions for the fungus and eggs. Ants do not use sound like humans. Instead, they communicate using pheromones, volatile chemical signals used to mark paths, alert danger. When an ant discovers food, it leaves a scent trail on its way back to the nest. Other ants follow this trail to the food source. The richer the food supply, the more intense the pheromone trail becomes, leading to even more ants joining the effort. This mechanism creates highly efficient collective behavior, allowing thousands of ants to act in perfect coordination, without any central leadership. Not all ant species build permanent nests. For example, the army ant, Esotin burchellii, lives a nomadic lifestyle. The entire colony is constantly on the move. Instead of digging tunnels, they construct a living nest, or bivouac. Hundreds of thousands of ants interlock their bodies to form a tightly woven, stable structure. The queen and brood are kept safe in the center of this living mass. During the day, the colony fans out to hunt. At night, they return to the bivouac to rest. After a few weeks in one location, the colony dismantles the nest and continues its journey. With extraordinary reproductive abilities, a tightly tiered social structure, and sophisticated nest-building techniques, ants have become the most successful insects in evolutionary history. In the Amazon rainforest, where the struggle for survival is intensely competitive, it is precisely their social organization and discipline that have enabled ants not only to survive, but to dominate the ground-level ecosystem, playing a crucial role in maintaining the structure and health of the entire rainforest. Though small in size, ants stand as a perfect symbol of cooperation, innovation, and resilience in the natural world. Your fascinating experiences in the comments below. Each story you tell is like a fresh green sapling, nurturing the life of the Amazon rainforest. Let's help preserve the beauty of nature so it can thrive and endure forever. Don't forget to like, subscribe, and hit the notification bell to join us on many more magical adventures, because the next chapters of our Amazon series are still waiting to be told. Thank you, and see you next time.